graph. This is a sine graph, but it's not one period, it's many periods. Okay, so we can count how many periods are there. 2 pi is one period. This is another period. That's one period. Go for here, here, and here. And the middle is 1. This is the y-x-axis. Okay, so we can see many 1, 2, 3, 4, 5, 6 periods here. Okay, what I want to do now is consider a graph above y equals to sine x. Okay, this is the y equals to sine x graph. Use the graph to solve sine x equals to half. Okay, I don't really want you to solve out anything. I want you to think about where is those points. First of all, let's draw y equals to half, this horizontal line on the graph. If we can draw y equals to half, because y equals to sine x and then y equals to half, the intersection will be the solution. So, well, 1 will be here. Okay, the maximum line is 1, then the middle is a half. Okay, here will be a half because the maximum is 1, then the middle is half. Okay, how many intersections can you see on this graph? A lot. 2, 4, 6, 8, 10, 12, 13, 13, 1, 13. But like, if you just think about the period in between 0 to 2 pi, okay, if you just think about the period in between 0 to 2 pi, okay, the first question is, sine what will equals to a half? Sine what equals to a half? Pi on 6. Okay, so what you will know is this point is pi on 6 already. Yeah, this point is pi on 6 comma half, because that's the first value you can give sine equals to half. Okay, within 0 to 2 pi, can you think about, well, look at the first period. Look at the first period. There are 2 intersections, right? In between 0 to 2 pi, there are 2 intersections. What's the other one? The x value, like the x value, pi on 6 comma half. Yeah, coordinates. The x value is pi on 6. Sine pi on 6 equals to half. So that's why it's the intersection.
It's a half.
Hmm?
How do you know it's a half?
Because we draw a half. We draw y equals to half. We find the intersection between sine. We find the intersection between y equals to sine x and y equals to half. And then sine x equals to half. So sine what equals to half? X must be pi on 6.
Yeah.
Gives you half.
Yeah.
Okay, let's think about the other thing. Like in each period, there will be 2 intersections. Well, I want to find the second one in the first period. It's a positive value, right? It's positive a half. Let's first think about which 2 quadrants will give you positive sine value. 1 and 2, right? Well, those 2. Okay. In the first quadrant, we have this angle, pi on 6. That gives you a half. What angle do you think in the second quadrant will give you Well, in the second quadrant, what value will give you a half as well? Remember, the big angle will change to reference angle. Yes, 150. Yeah, what's in pi? 5 pi on 6 is the symmetrical one. Because if you think about this angle here, you will change into the reference angle. That's pi on 6. Plus is positive, so we don't negative it. So 5 pi on 6 and pi on 6 will give you the same sine value. So therefore, 5 pi on 6 will be the next value. Okay, the next value gives you a half. So this point here is 5 pi on 6 comma half. Okay, you can find all these special values in the first quadrant. Let's have a think about this. Okay, move to the second period. What do you think this point will be? Just give me an equation, not necessarily give me a value, like what you can tell me. 2 pi plus this. Okay, and how about this point here? We have 5 pi on 6 plus 2 pi. Okay, if I move on to the next one, what do you think the point will be? Plus what? 4 pi. And this one will be 5 pi on 6 plus 4 pi. Okay, how about this side? What's this point will be? Yeah, pi on 6 minus 2 pi. Minus the period, this will be 5 pi on 6 minus 2 pi. Okay, now what we can see, we have infinitely many values, right? If you keep going with the graph, it will intersect forever. Like there are infinitely many solutions. What I can write now is, well, after I find the first two values in the first quadrant, all the other values I can figure out. So what I can write now is the solution. Well, there's infinitely many solutions. It's impossible for me to list them out. So what I can write is, x will equals to what? X will equals to pi on 6 plus 2 pi times k. X can also be 5 pi on 6 plus 2 pi times k. And you should also write k belongs to z. Let's have a think about what I have right here. Okay, what's the k represent? K is integer. Can you tell me what k value can be? Like, list some number for me. 0, 0, 1, 2, 3. Also, the other side. -1, -2, -3. Okay. So what you're actually doing here is you sub different k values. You will add 1 period, 2 period, 3 period onto pi on 6. Or you can subtract 1 period, 2 period, 3 period from pi on 6. If k equals to 0, you just take pi on 6. You can reach all the values, right? Think about, if your k is 1, you add 2 pi, reach the second period value. If k equals to 2, you add 4 pi, you reach the next value. If k is 0, is pi on 6, is the value we just solved out. If you put -1 in, it's minus pi on 6, minus 2 pi, you have this value here. So using this equation, you can express, like, represent all the solutions. There's infinitely many solutions.
Does z equal 0?
Yes, integer, all the integers. 0, 1, 2, 3, 4, -1, -2, like forever. This is called the general solution. This is called the general solution of sine and cosine.
So you can use either one of these two?
No, they are both solutions. You need to give both.
Oh.
Because one represents this one. And adding all 2 pi minus all 2 pi. And the other one represents this one. Adding all the 2 pi's and subtracting all the 2 pi's.
So if it's positive, then this first equation would be the one on the left-hand side.
If k is positive, it represents all the values on the right-hand side of pi on 6. Okay, can you see? This is my group 1 value. And this is my group 2 value.
And if it's negative value, then
And you go that side. You go that side. You go this side.
yeah.
Yeah? Okay. Well, if I change color, this is a purple, this is a purple. So the first line represents all the pink value, and the next line represents all the purple value. Okay? All right, so this is the key idea of how to solve sine and cosine graphs. So what I want to talk about here is, you just need to solve out the first two value in a period. Okay, first two value in between 0 to 2 pi. Think about in between 0 to 2 pi. Sine what can be half? Just think about the first two. There will be always two values. And next thing is you just adding period onto that. Well, this is a pure sine x graph, which is easy, like you just add 2 pi. But if you have sine 2x, you're not going to add 2 pi. You will add pi, because the period is pi, it's no longer 2 pi. So you need to add the period on 1 period, 2 period, 3 period of that equation. Okay, of that equation. I'll do an example, but write something down first. Sine something equals to a. or cosine something equals to A. If A belongs to, if A does not belongs to plus minus 1, you need to give two values in between 0 to 2 pi. Okay, if A is not plus minus 1, you need to give two values in between 0 to 2 pi. For example, in this case, you give pi on 2 and 5 pi on 2. Same as cosine, you always need to find two values in the first period. But if A is plus minus 1, only one value required. Okay, only one value required in between 0 to 2 pi. You just need to give one value, but that's the extreme case. Only 1 and minus 1. Why 1 and minus 1 only give one value? If I draw y equals to 1, how many intersections can you see in one period? 1. Okay, there's only one intersection. If you draw -1, again, there will be only one intersections. Because in between 0 to 2 pi, there's only one angle can give you 1 or -1. Okay, so therefore you only need to give out one value, and then you're just adding period or subtracting period on that one value, and that's it. Okay, so 1 and -1 is special. If you draw any number in between 1 and -1, you will always have two intersections in one period. But 1 and -1, you only intersect at the turning point. That's the highest point. You just have one highest point in each period. And then you're adding period on that to give the next period value.
Is it like unit circles, like you always have maximum with 1 and -1?
Yeah, 1 and -1. Like, you can rearrange the equation. You can rearrange, divide any coefficient to that. So I'll show you the example after that. Let's go to the example, not that example first. Let's go to this example first. Okay, have a look at this example here. I'll show you a proper way of doing it. Last lesson, I haven't, last example, I haven't restricted the domain. The domains are, like, everything, okay, everything. But in this one, I have restricted domain in between -pi to pi. So what we'll do first is rearrange the equation. I just want the pure sine x on one side and all the coefficients to the other side. Okay, next question, okay, after you make it into this form, you want to think about sine what equals to 1 on root 2? What do you need to do if you can't remember values? Think about table. Well, no, if I make this equals to root 2 on 2, that's not 1 on 2, that's root 2 on 2. Pi on 4. Okay, you get one value. What's the other value must be? Okay, sine. This is a positive, right? Which quadrant? Pi on 4 is here. That's the old quadrant. What's the other quadrant give you a positive sign? Second, right? And it's symmetrical because you need to have the same reference angle. So which is 3 pi on 4. So you have pi on 4 here. And this one gives you 3 pi on 4. Okay, so, okay, sine pi on 4 gives you root 2 on 2, sine 3 pi on 4 gives you root 2 on 2. So what I should write is 2x plus pi on 4 equals to pi on 4. 2x plus pi on 4 equals to 3 pi on 4. Okay, two solutions because you need two solutions. So the bracket must be pi on 4 or 3 pi on 4. to give you root 2 on 2. Okay, let's see what x can give you that. That is x equals to 0. That's easy to think about. Power 4 is power 4. X must be 0. Okay, this one. 2x equals to minus 1 is 2 power 2. So it's pi on 2. 2 power 4 power 2. Then x is power 4.
Using the quadrants, how does this angle with 3 power 4?
3 power 4's reference is power 4, right?
Yeah.
So 3 power 4 can be changed into power 4.
Yeah.
Remember, think about when you do.
Yeah.
Then you have the same value.
Yeah, but how does the 3 power 4 relate to being the second point here? Okay, because that's what it is.
Yeah, it must be the second, like in between the first period, 0 to 2 pi.
Okay.
In between 0 to 2 pi.
If it was 10, would you put it in the...
We talk about 10 later. Do you understand? It's not necessary on that point, so that's just a general idea on the simple sine x graph. But this graph has been stretched, dilated, moving, like it's not necessary the first.
We're just using a unit circle to find...
Yeah, to unit circle to find another. With the same y value. Any questions, everyone? Okay, after I find two values, now those two x values must be next to each other because power 4 and 3 power 4 are the values next to each other gives you sine what equals to root 2 on 2. So now you solve out x equals to 0 and x equals to power 4. You need to use those two values. Okay, those two values must be in one period, like within one period. Now you think about other period values. So what you need to do is you find the period. Okay, you need to work out the period first. Okay, just warn you, different teachers teach different ways in solving and sketching for circular function, and this is the most obvious topics. You can see different teachers teach quite differently. So if you already learned it in one way, and I think my way is not really the common use ones. I know there's another way to do it, but I don't like that method. So if you think it's better to use your way, just use your way, that's fine. I can understand what you're doing. If you haven't learned my method. If you learn that and you don't understand or you're confused about both methods, come to ask me, I can explain it to you. Okay, so do not get confused. If it's the first time you learn it, good. Okay, you just learn this way. If it's not, try to think about which method is suitable for you. Okay? And if you're confused, come to ask because a lot of students confused about that. So period is 2 pi divided by n. N is 2. And period is pi. Okay, period is pi. You know for one value, you're adding period will definitely move on to the next period value. So the general solution I can write now, like I'll write here. General solution will equals to x equals to 0 plus pi times k. And x also equals to pi on 4 plus pi times k. What's pi? Pi is the period. What's k? You must include k, okay? K belongs to z. You must write this. If you don't write that, you don't have the correct general solution. Okay, that both of that equation must be shown to get full marks. Okay, this is the general solution. Okay, now it's not enough. Why it's not enough? Because the domain is restricted in between negative pi to pi. You can't say, oh, all the values here, you try. Okay, you need to give the specific values. So what we do for this method, I will try start from k equals to 0. Okay, it won't be many. Okay, it won't be many. So x equals to 0, x equals to power 4. Those two values still within the period. So we will move on to the next. We make k equals to 1. We set k equals to 0, and now we set k equals to 1. We set k equals to 1, we have pi. The next value we have will be 5 pi on 4. Do they satisfy? Which one not? 5 pi on 4 not. Okay, so we don't want that one. So we stop at pi. So that's the end of it. Okay, we're not going to try k equals to 2 because it's definitely over the domain. So what we'll do now is going backwards. K equals to -1. Okay, k equals to -1, x equals to -pi. And this one, x equals to -3 pi on 4. What's the question?
Where are you subbing it?
K.
Oh, okay.
K. It's a general solution. You don't know what are they yet until you sub k, give k values.
Wait, do you just sub?
It's not random point. You start from 0, you go down, and then you go upwards until you go outside the domain, until you reach the domain. Okay, let's look at the most left-hand side value, -pi. It's just touching the domain, right? It's touching the domain already. You're not going to try the next one because it will definitely be over. So the values I can have, the conclusion I'll make is, so x equals to -pi, -3 pi on 4, 0, pi on 4, and pi. Okay, these values are the 5 values you should answer.
But what about all the other k values?
You don't care because it's out of the domain. They are actually values, but the domain is restricted in between -pi to pi. Your x can't be other values. Your graph stop there.
What about like k is like
You can't because you must add in exact period, like 1 period, 2 period, 3 period. You can't add half period.
Yeah.
If you add half period, it's not at that spot anymore. Yeah, have a think about this question. I'll give you a couple of 1 minute to think about it. What we have done overall, we rearrange the equation to make sine equals to some special values. Root 2 on 2 is the special value. Then we think about sine what give you root 2 on 2. You have pi on 4, but at the same time you also have 3 pi on 4. Use those two values to solve for x. We have 2 values for x. We find the period, then we write the general solution. Is the first value adding period, how many period, and the second value adding many period. And you need to write k belongs to z. That's important for general solution. After you write out the general solution, you want specific solutions, like which ones are the ones within our domain. So we sub k equals to 0 first, and then we move to the positive side, going down until we reach the domain or go outside the domain. And then we go backwards to reach the domain or go outside the domain. Then we stop. Okay, those values are the values I should have for this answer. Any other questions? Okay, if you don't have questions for that one, let's try the next one. Okay, this is kind of like a little bit special. Okay, what we have is cosine 3x minus pi on 3 equals to 0. Okay, we can divide the 2 on both sides. Cosine what equals to 0? This one's easy. Cosine what equals to 0? No, cosine 0 is not equal to 0. Pi on 2 and 3 pi on 2. Okay, is here and here. Okay, it's there and there. So what we will have is that equals to pi on 2. That equals to 3 pi on 2. Actually, I don't like this value. It looks very bad. Okay. Well, let's solve for it. So 3x equals to 5 pi on 6 if you add them. 2 pi on 6, 3 pi on 6, 5 pi on 6. Then x equals to 5 pi on 18. Next one we have 3x equals to 2, 9, 11 pi on 6. 2 pi on 6, 9 pi on 6, 11 pi on 6. So x equals to 11 pi on 18. Okay, that's why I don't like the value. It's a little bit terrible. What's the period? 2 pi on 3. 2 pi on 3 is the period, divide by n. Okay, 2 pi divided by n is the period. So my general solution x equals to 5 pi on 18 plus 2 pi over 3 times k. The second one we'll have is I'll write down that side. X equals to 11 pi on 18 plus 2 pi over 3 times k, where k belongs to z. Okay, what I want to do now, like, it's not necessary, but I just want to make onto the same denominator easy for my calculation. So is 5 pi plus, well, I want to make a denominator 18. I need to times 6 on top and bottom. So that's 12 pi k over 18. You can make it into the same denominator. It's just easy for my calculation. And the next one, I should have 11 pi plus times 6. So it's 12 pi k over 18. Okay, k still belongs to z. Okay, it's all for easy for calculation. So it's still period times k. Okay, it's period times k. Now, because domain is negative pi to pi, so what I'll do is I'll try k equals to 0 first. Okay, k equals to 0. X equals to 5 pi on 18 and 11 pi on 18. No problem with that. Okay, still not beyond pi yet. We try k equals to 1. If k equals to 1, okay, if we sub 1 in, that's 17 pi on 18. And that's 23 pi on 18 if k equals to 1. Do we keep trying or we don't?
We don't.
And should I reject anything?
23 pi over 18.
Yep, 23 pi on 18, which is out of the domain, is beyond pi. So I'm not going to keep going for k equals to 2. Then don't forget we need to go for negative as well. K equals to negative 1. Okay, k equals to negative 1. See what we'll have. If that's negative 1, that's negative 7 pi on 18. And the other one, we have negative 1 is 11 minus 12 is negative pi on 18. Should we keep going? Yeah. So k equals to negative 2. X equals to, okay, if it's negative 2, this is negative 24. 5 minus 24 is negative 19 pi. Okay. Negative 19 pi on 18. And the other one is 11 minus 24. That's negative 13 pi on 18. Should we keep moving or not?
Yeah.
Why not? Negative 19 pi on 18 is out of the domain. It's less than negative pi already, so we don't try the next one. So what we will have Therefore, we'll answer. So, x equals to negative 13 pi on 18, negative 7 pi on 18, negative pi on 18, 5 pi on 18, 11 pi on 18, 17 pi on 18. Okay, that's it. 2, 4, 6. Okay, that's my final answer. Okay, this is my final answer. Any questions? Which one?
Like at the very start, 3 minus 2.
Here?
Yeah.
Cos pi on 2 equals to 0. Cos 3 pi on 2 equals to 0. That's the unit circle thing, like 0, 1, 0, negative 1. X value represent cosine. Here, 0, 1. So x value represent the cosine. So cosine pi on 2 equals to 0.
Is that just the thing that you memorized? Or is that something that we worked out?
That's how you work out from the unit circle. Remember the unit
I
circle?
didn't understand why you worked out here.
That intersection is everyone. That one is 0, 1. That one is 0, negative 1. X value represent the cosine value. So that angle is 90 degrees. That's pi on 2. So that's why cosine pi on 2 equals to 0. And this one is 3 pi on 2.
Oh.
Cosine 3 pi on 2 gives you 0 as well. X value represent cosine. Yeah.
Oh, and also sine.
Any other questions? If not, let's look at the next one.
I just lost it.
Okay, last one. Last one, well, there's a bracket. Okay, last one, we have a bracket there. So sine 2t minus pi on 4, that's the angle. What we have, this one will be a special one. So sine 2, well, I can open the bracket. That's 2t minus pi on 2. That equals to 1. Okay, we have sine or cosine equals to 1 or negative 1. That's the special one. And you will like it because there's only one angle. Okay, there's only one angle you need to consider. You just need to think about sine what gives you 1. Sine pi over 2 gives you 1. Okay, so 2t minus pi on 2 should be pi on 2. Because pi on 2 gives you 1. And we just do everything as the same. So 2t equals to pi. T equals to pi on 2. What's the period? Yep, 2 pi over 2, that's pi. So general solution will be t equals to pi on 2 plus pi times k, where k belongs to z. Okay, k belongs to z is something you must write. So period times k. Okay, period times k, and plus the value you have originally. I can make the same denominator. That's 2 pi k over 2. Pi plus 2 pi k over 2, where k belongs to z. Okay, just make the same denominator there. Easy for my calculation.
Oh, I know.
And my domain is pi on 4 to 5 pi on 4. Okay, pi on 4 to 5 pi on 4. So I will have k equals to 0 first. T equals to pi on 2. Okay, so remember we have pi on 4 to 5 pi on 4. Okay, k equals to 1. T equals to 3 pi over 2. Do you think we should keep going or not? Why not?
Just
Oh, yeah.
So it's 6 pi on 4 already, right? 6 pi on 4 already. So we don't have this one. Okay, so that's easy. We check -1. T equals to negative pi on 2. Do we have that? Yes or no? No. So we just have pi on 2 as my value. Okay, pi on 2 is the only solution for this one. So T equals to pi on 2. Okay, so I have shown you. Wait, I haven't. I need to show one more. Okay, I need to show one more, which is the solution. The example we do yesterday, because we haven't talked about the negative case. We just talked about the positive case. Haven't talked about the negative case. I just have a start with you, and you do the rest. Okay, let's copy this down. 2 cosine 2x minus pi on 3 plus 1 equals to 0, because I want to solve for x-intercept. So what I will have here is 2 cosine 2x minus pi on 3 plus 1 equals to 0. Okay, solve for x-intercept. Okay, still do the same thing. We have cosine 2 bracket x minus pi on 3 equals to minus a half. Minus 1 divided by 2 minus a half. Now all we have done so far is dealing with positive. Okay, dealing with positive. So what happens if it's a negative? Okay, ignore the negative first. Let's think about cosine what gives you a half? Pi over 3, right? Pi over 3 gives you half. Okay, now you want negative cosine. Which two quadrants you can achieve negative cosine? Second and third, right? And with a reference angle of pi on 3. Because you want the ratio a half, so you need the reference angle of pi on 3 here. So therefore, the two angles you will have negative a half will be 2 pi over 3. And then this one will be 4 pi over 3. Okay, 2 pi over 3 and 4 pi over 3. Because this is the sine quadrant, this is the t quadrant, then you can achieve negative cosine. You want that ratio a half. Only reference angle pi on 3 can give you that ratio. So therefore, you will have 2x minus pi on 3 equals to 2 pi over 3. And also 2x minus pi on 3 equals to 4 pi over 3. Okay, the angle will be 2 pi over 3 and 4 pi over 3. Therefore, you can have the ratio negative a half. It's in the second and third quadrant, must be negative. Then you think about the ratio. Pi on 3 is the reference angle. So what's the actual angle in that quadrant? You think like backwards, okay? It's basically think backwards. Okay, I'm not going to keep going from here. What I want you to do to keep finishing it, solve for x, find the period, write the general solution, check k values, and the domain is 0 to pi. Okay, domain is 0 to pi, and find the x-intercept. Well, as you can see, there are 3 x-intercepts. One is 0, the other one is pi, and there's somehow, I think there's 8 pi over 12 or something like that in the middle. So you should solve out 3 solutions for this question. Okay, just finish it, give a proper working solutions. You need to solve for x, find period, write general solution, check k values, and in the end to confirm what are the x solutions. That's a lot.